Whey protein. Hi there, how's it going? Welcome to another session of Brain Training, a place where I train my English by explaining LeetCode solutions. And today we are back again with the 912 sorted an array. The question asks us to rearrange the numbers, the integers within a nums array in ascending order, which means rearrange them from the smallest to the largest. That's what it is. And the question also expects us to come up with a algorithm that runs an O n log n time complexity, but that's not going to be possible today as well because we're going to use insertion sort. Even though this is still a quadratic time algorithm or n square algorithm regarding time complexity, it is a very efficient algorithm. So without further ado, let's dive right into the implementations details for insertion sort. How insertion sort works. Just like selection sort and bubble sort, we're going to have multiple passes. We're going to iterate over the entire array multiple times. And for each pass during this sorting process, we're going to keep a section of the array sorted. We're going to focus at the beginning of the array, starting from the index 0. And in each pass, we're going to include a new number to this session, the sorted portion of the array. We keep including new items and placing those new items at the correct position. And by the end, we have the entire array sorted. So here, at position 0, this will be our sorted region. Here we already have the 5 that is sorted with itself. We are already good to bring up a new item, which will be in the position 1. I will point to the next item we want to add to the sorted array. Another pointer we need, another variable, is j. J will point to the last sorted number in our sorted session. So right now, j is pointing to 5 because 5 is the last sorted number. We also need a new variable. We're going to call this new, but it could be new item, which what this variable does is it holds a copy of the number we want to include to this sorted session of the array. First thing we do, so in the first iteration, we have this, let me bring the snippet, the code snippet we're going to use. That's the most important part of the algorithm. So how this works. So let's give this a try. Another sip. So first pass, y is pointing to 1, to the next item we want to add. We make a copy, place at new, so new is 2. So right now we're gonna do we are gonna check j 0, so this is good. Nums at j, so nums at j is 5, is greater than new. It is, this is true, new is 2. So what we're gonna do is, we're gonna move 5, I'm gonna make a copy of 5 and place it here. That's what we did with the array. This is why we hold a reference, a copy, because we just lost our number. This will happen here in this line. The next line is minus minus, so j now is out of bound. Is this minus 1? Didn't exist, so we don't have a position minus 1, but it's okay. So the next time we try to iterate here, we're going to break this loop, and now we're going to replace j, because j is, like I said, j now is out of bounds, so that's why we use j plus 1. J plus 1 is 0, so j is back again to the correct position, and we are adding the new item to this position. So 2, and that's it for the entire pass. Let's go to the next pass. So second pass, let's initialize our variables. So now the next item we want to add is 3, so is it at position 2. This is outer loop taking care of the next item we want to add. In the inner loop, now the last element in our sorted portion, this is our sorted portion already, so the last element in it is 5, so position 1. And the next thing we have to do is make a copy of the item we want to add, the new item we want to add to our sorted portion. and start our algorithm again. Same logic again. So this while will run while j is less or equal to 0. That's true. And nums, so the item that j is pointing to, is looking at, is greater than the new item we want to add. That's true. It is. What we're going to do, we're going to move the item that j is pointing at to this next location here. 5 is now is here, and j will move one position behind. And we are back again with the for loop. This condition is still true. J is less or equal to 0. It is. J is less or equal to 0. And the number that j is pointing to is greater than the item we want to add. It is not. This is not true. So we are not going to execute this code over here. We are out of the loop. And then, so the last thing we have to do is just place the new item in its correct location within our sorted session, which is j plus 1. So j goes back one step. This is the last valid position. And we make a copy of our new item. And that's it. We are done. This algorithm is so clever. Move items to the left and then place at the correct position. We are insert in the correct position. That's beautiful. Let's go to the third pass. So third pass, guys. We are reached the end, as you can see. So the last item we want to add is 1. So we just make a copy of it. Don't lose it, right? And j is pointing to the last item at our sorted portion. Now we are back again with our code, the most important code, that is this inner loop. So j is less or equal to 0. That's true. And the item at j is greater than new. So let's check. That's true. So what's going to happen? We're going to first of all, we make a copy of it. So here, the copy of it. Place at this position to j. Position at j. What? Yes, j plus 1. We place at j plus 1. This is correct. So as you can see, we already lost the item. Next thing we do, move j backwards. One step behind. And run again. That's true. Nums at j is greater than the new item. It is. So what we're gonna do is same thing. Make a copy of it. Place to the j plus 1, and then move j one step behind. And now still true. Position 0, and the next verification is also true. So what we're gonna do is make a copy of it. Move to the position j plus 1 and one step behind. So now j is out of bound. That's not true anymore. We are out of here and we are good to place. So this must be j plus 1 must be the correct position. 1 will be here and j plus 1, and we are done. And as you can see, the entire array is already sorted. That's all we need. Works beautifully. This is why the insertion sort is the GOAT among the quadratic time algorithms, sorting algorithms. It's so neat. It's beautiful, beautiful. Now let's code it up from scratch. So first thing, as you saw, we start our outer loop at index 1 because we know that the index 0 is already sorted. So that's our session, our sorted session, until all the way to the end of the array. And the first thing we have to do here is just save a copy, new item. I'm gonna call this new item. Make a copy of the number I is pointing to. So this is the new item we want to add to our sorted array. The next thing we do here is declare j, because we're going to use a while loop. We have to initialize our variables here. J start at the last sorted index, which is I minus 1. And we are good to start the inner loop, jump into the inner loop. The same code we already covered. And the last thing by the end of the outer loop, we just have to return nums. Let's give this a test run real quick, just make sure there's no typos here. And let's submit this. Let's see if finally we can resolve this problem. We do. Oh my goodness. For a quadratic time algorithm, look the performance. Look the performance. Quadratic time. No recursion needed here. We're not talking about quick sort, merging sort. Come on, man. For a quadratic time, that's neat. Regarding time complexity, like I mentioned, n square, time complexity, space complexity, O of 1 for space complexity. No extra space required for this algorithm. I hope this make your day happier. Learning about insertion sort. I never have heard of it before, but now I feel a better, I feel a happier person after knowing about this algorithm. It's amazing. It's amazing. Hope you enjoy it. See you in the next one. Bye bye.